move on to the next talk, and we will move on to the field of education. And Rianne Conijn will tell us everything about optimizing human and AI collaboration in education to support learning. Please welcome her.
Oh, that's bright. Okay. Today I want to talk a bit about learning, and hopefully that is one of the main aims of you sitting here in this room, or at least I hope so, for this AI Summit, to learn something today. And my research is usually about learning and learning in higher education, so in universities, but of course learning goes way beyond that. If you think about learning, and especially lifelong learning, we see that we hopefully learn from just the moment that we are born up to, let's not put an end date to it, right? But we see that a lot of this learning takes place online, and also it becomes more and more asynchronous. So that means that sometimes when you're learning, you're not directly there with the teacher in a room. So you're just watching some videos, or you're listening to a podcast that might have been presented months or maybe even years ago. So there it becomes harder for a student or for you as a learner to get back to that topic, or to ask questions, or to maybe improve your learning, or to find a strategy on how to get more knowledge on that specific topic. So a big challenge is, when we are talking about this kind of learning and this lifelong learning, is how can we now use AI? Given that there are so many opportunities, how can we use that then to improve our learning? And luckily, there are already quite a bit of examples of AI used in education that show some of these advantages. And one maybe of the simplest form is a type of a learning dashboard. So in this kind of dashboards, this kind of applications, we see that we can provide learners with some information about what kind of skills they already know, but also what kind of skills they might be lacking, or if there are specific topics that they still need to learn about. Other things in these kind of dashboards that might help are some kind of predictions. So based on the kind of videos that you've watched, maybe it would be interesting if you dive a bit more into a recurrent neural network. Or maybe you would like to revisit a specific topic because it seems that you're not understanding it fully. So a lot of potential here to feed some information back to the learner about how they are doing and how they can improve what is going on. Another example of where we see AI in education is if you're talking about automated feedback systems. In this specific example, I'm thinking about writing, where students are asked to write an essay, and still, in this case, by hand, so not with the use of generative AI. They really need to do it by themselves. But then, of course, it's very time-intensive to provide feedback to all of these different students as a teacher. So an idea could be to have a system that actually already flags quite a bit of the errors that they see in their writing. And this is what these automated feedback systems can do, right? So they do not only grade, but usually they already also provide a bit more feedback about what kind of things can be improved in this case, the writing. So two different tools that can definitely already help us in our learning, but, and especially if you look into the literature, we see that there are quite still some criticisms about these systems. So first of all, what we see is that a lot of these systems really focus on the data. So you can say that they are primarily data-driven. We focus on, we just have data, so we just show it to you. But that actually doesn't always help learning in this case. You can imagine thinking about these kind of graphs or a smartwatch. That was very interesting for me in the first couple of months, but after a while, I got used to these visualizations and it did not help anymore, right? So we need to go beyond just giving or just presenting the data. A second thing is that we want to see is that we will need to make sure that if we then have these visualizations, that we also make it actionable. So it's nice to see, but we want to have some action. We want to be able to think about how we can proceed. And finally, one thing that we should not underestimate is that in a lot of these visualizations, in a lot of these feedback systems, it's not always clear for people that have a bit of lower data literacy to understand how they can interpret the data, but also how they can use them to their benefits. So basically what we see, we have all these nice systems, AI can play a huge role, but actually impact on learning specifically, so improving learning, is limited. And then next to that, what we also see is that people can try to abuse these systems. We also call that gaming the system, trying to see, okay, I now know that apparently based on this system, my essay was not long enough, I just add some gibberish in the end, and then maybe I get a better grade. So these, of course, are nice ways to trick a system. They are not ways to learn. So we need to move a bit further to make sure that we can actually learn with these systems. And that's exactly what my research is about. So in my research, I try to dive into 3 different topics, or at least the topics that I will be discussing today, is how can we actually optimize these kind of systems to improve learning. And I will talk about 3 different ways to do that. And obviously a combination of all of them would be best. Diving into things like theory-driven design, user-centered design, and also explainable AI. So let's start with the theory-driven design. Because my area of my research is about learning, it would be odd, but actually this is what often happens, that we are not diving into educational sciences. So we want to improve learning, so the first thing that we actually want to know is, how do students learn? What are important kind of factors that play a role if you think about improving learning? One of these things that we often see in the literature is the use of self-regulated learning. And this is a factor that is especially important if you think about lifelong learning, because students or learners, they need to be able to regulate what they are doing and think about what are the next steps in my learning. So there's an important part where students need to focus on planning their work, reflecting on their work, and trying to change what is going on there. Another important theory, and there are many more, but I just keep it to these 2 today, is effective feedback. So a lot of these systems, they give something back to the student. Well, in educational terms, we often call that feedback. And we know a lot about what kind of feedback works well and what kind of feedback doesn't. So in this case, we also need to consider these kind of practices if we try to give information back to the student. So one example of one of my research where we wanted to see, okay, how can we then give this kind of data back to our students and in a way that we represent these kind of theories that we know from educational sciences. So in this case, we collected all kinds of data from students interacting with the learning management system. So the system that we're using at a university is Canvas, and a lot of students just click around there, download some materials, watch some videos, maybe post a question on the discussion forum. There's quite a bit of interaction, and you could even say learning happening on these online systems. So in this project, what we try to do is give some of that information back to the students. So based on your interaction so far with the learning management system, how are you doing? What is your average grade? Are there specific kind of things that you've missed? Are there specific deadlines coming up? And in this dashboard, we made sure that we focused on supporting self-regulated learning. So we made some specific parts that really focus on planning, but also some specific parts that focus on reflection, just to help the students see, okay, how can I now improve my learning, and how can I actually act upon these data? So so this is just one example of showing how we can then use theory-driven design to improve the impact of these kind of AI systems. Another thing that we need to think about is when we are giving these tools to students or our users, is that, of course, they need to be able to work with it. And one way to do that can be to use user-centered design. And the important thing is there that you identify what the specific stakeholders are, what they want to do with the system, how they will work with the system, and so on. So a common solution then would be to have different types of design cycles. We usually call it iterative design, where we, together with the users, start to develop a system, improve upon it, test it, iterate, and so on and so on. So this is what I did in one example for teachers, where we were interested, can we give teachers a bit more feedback on the different kinds of writing, the different kind of assignments that their students make, just so they see what are common errors. Are there specific kind of things that I need to pay more attention to in my class? Are there specific students that really struggle and that might need some extra attention? So in this case, to create this teacher dashboard, we were really interested in, okay, what are the current practices for teachers in terms of providing feedback? Because that could help us to see, okay, what do we then need to bridge, and what kind of help can an online tool provide to make the teachers more effective in their teaching. So in this case, we started several co-design sessions where teachers actually started to interact and try to play with different types of visualizations with a specific focus on, okay, based on these kind of visualizations, how can we now assure that they're actually actionable and that teachers will do something with the information and that it doesn't end somewhere in their trash bin after a day because I felt, okay, it's nice, but I don't continue with it. So as an example here, what we saw that a lot of the teachers were interested in were basically two types of activities. And the first one was focusing on more class comparisons. So overall, the whole class, are there kind of common errors? Do we see some things that we need to work on in our classes? And another example was based on more the individual comparisons. So there they felt like, okay, it would be interesting to see that there are two students with two completely different approaches to the writing assignment, or two different approaches to how they go about writing a specific essay, and then they can actually perhaps learn from each other. So what if we give that then back to the student and they learn from their peers? So two examples where they really already envisioned the actions, and from the actions we went back trying to make sure that we actually created a tool that helps teachers with getting to these types of actions. And then the third topic that I wanted to talk about is, or solution basically to make the AI more effective, is the use of explainable AI. So what we often now see in education is that teachers or students don't really understand what is going on in the system, and therefore also not usually use it in an optimal way. So we actually want to explain what is going on, but in a way that it can improve their understanding of the system, but especially also things like trust or their reactions upon the system. And the interesting thing is, if we think about education and we explain what is going on in, for example, an automated feedback system, you can already also see that as a form of feedback to the student again. Because the system explains, okay, I gave you this specific grade, and then the student, because of this reason, and the student might think, okay, but that then also means that these are the reasons why my essay was not good enough. So in this case, the explainable AI does not only help students understanding the system, but it might also help them in understanding the things that they did wrong. So if we think about explainable AI in education, we actually see that it's not used that often. The empirical evidence is super limited. I just want to show two state-of-the-art examples that we have now. So imagine yourself back as a long time ago, where maybe some of you learned some graph theory, and you would get a kind of, at some point you would get a hint showing, okay, maybe some additional explanation on how to change this exercise. So you might then wonder, why did I get this hint Why does it pop up now? Do you think I'm not a good enough student? And so on and so on. So here, then, explainable AI might look something like this. And interestingly, if you go further in the paper, actually it goes on a bit like this. And I will not ask you to read it, but maybe think if you are a student, will you read all of this? Will you understand all of it? So this is maybe a bit of a bridge too far, right? So there is quite an interesting play where we need to see, okay, what then do we need to explain to the students? Another example of an automated essay scoring system that gives some kind of grades on different kind of rubrics, maybe about your idea, about your structure, and a specific explanational system, this case based on SHAP values, looks like this. Just give you a couple of seconds, type this in. So basically, if you would read this graph, you would see apparently word count is one of the most important features. And then the next important feature, it's HDD 42 something something. So maybe you can already understand that also this is maybe not the solution for a student, right? I have no idea what is going on here. I have no idea how to improve my essay based on this. Maybe I know because apparently word count is super important, so I'll just make it longer. But there we are at the issue where we are talking about correlation, right? Not causation. So the fact that word count was an important factor doesn't mean that just adding more words to my essay makes it a better essay. So here we see that for these kind of explainable AI systems, we actually dive into the same kind of circle that we've seen before. We need to focus on theory-driven design, but also on user-driven design to make sure that we actually use these kind of explainable AI systems in a good way. So if we dive into that, we want to know what do we then need to show to the students and how. First, a bit of user-centered design or evidence from a user experience design is basically similar as what I showed before. Dive into the needs of the users. So in this specific example, we see all these different kind of questions that students or users might ask, and that explainable AI might help them with. We can think about the kind of mental model that the student already has about the specific system, and what is then the gap? So what is kind of the missing information that we need to add to make sure that a student actually starts to understand how the system works? If we then dive a bit further into theory, we actually know quite a bit from the social sciences in terms of how people make explanations and what kind of explanations are helpful to them. Think, for example, the case that explanations need to be selective. So we do not want to show everything at once. And we also see that not every explanation works the same for every user. So there's no one size fits all. We also see that explanations actually usually is a bit of a social encounter. So if you try to explain something to one of your peers, there's usually a bit of interplay going on. You're going back and forth. So even in these kind of explainable systems, we would like to see some interaction going on there. Another example of good explanations would be to make it contrastive, because that's usually how we like to think. That makes it easier to contrast these things to understand what is going on. And finally, of course, we need to have some truthfulness in there. This is actually a kind of a bit, there is quite a bit of research debate, because then how truthful do you need to be, right? Sometimes just a bit of an abstraction that's not completely the truth might still have a very valuable way for the student, because it just is a bit more abstract and just does not go into all the little details and all the little depth. Another field that we can draw some insights from is from decision theory. So actually, if we think about humans, what we know is that humans do not make rational decisions. We are no rational decision makers. We just don't have the time, usually, to make rational decisions or to outweigh all the different costs. But usually we use some kind of heuristics, some quick and dirty ways to come up to a decision. This also means that these decisions come with some biases. or could mean. Because we make them in a quick way, sometimes you just cut some corners here and there to come to a specific conclusion. And this is also an important thing if you think about users needing to make a decision based upon their AI. So we need to ensure that the explainable AI goes away in where we avoid these kind of biases to be happen, where we make sure that we cannot dive into these holes where we just see the same explanation over and over again and then just believe that it's true. And then we start to think and do not really put our calibrated trust into the system. So these are just a couple of insights from theories that can help us making these kind of explanations more helpful, in this case specifically if we think about the educational context. So if we try to wrap all of that up, we actually see that in this case, in an educational session, especially if you think about explainable AI, there is just no one-size-fits-all solution. We really need to think about what is the goal of our specific tool or of our specific explanation. What is the context? So is it about specific kind of courses? Do we want to know something about learning? Do we not want to know something about writing? Goes deeper into that. And there are a lot of characteristics of the user that are important to take into account. So these are all these different things that we need to test to see what kind of explanations work well in what kind of cases. And there we can also see that these kinds of more iterative systems or more systems that can change across the user might be more beneficial. And that is something that I will be working on at least in the upcoming years with the NWO funding. Just as a take-home message, if you want to improve your learning with the use of AI, of explainable AI, well, the first thing that I actually did not talk about, but that I just assumed that was there, is having good data, good models, something that works. Because if you don't have an appropriate model, of course, it does not make sense to explain it. So we need to start with something that works, and luckily we have a lot of examples, actually, that works very well in education. The second step is we need to think about, okay, what do these data actually mean? So put them into the context of a specific course, put them in the context of a specific learning line that you have maybe over time. The third thing is understanding what users might need and make sure that you can actually action or act upon the data. And the final thing is focusing on some effective strategies. So based on theory, know what works and what does not. Thank you.
Thank you very much. Are there any questions on this topic? Because I have one for sure. Is there anybody else that wants to ask a question? Here.
Yeah, thank you so much for the great presentation and for super interesting research. I was wondering, so you pointed here out that the students get demotivated if they don't fully understand these interventions and tasks. And when we come from the motivational theory, so like some thoughts from your side that we kind of give them some positive feedback or something that would motivate them more, or what do you think can that be achieved?
Yeah, for sure. So from motivational theories, we know actually that it is important for students to be motivated because that also improves their learning. And if we take that back, for example, in feedback creation, what we usually want to see is provide students with some feedback that they can relate to, or some feedback that they actually can attain, or make sure that we focus on learning materials that they feel are related to them, but also that are not too advanced. Because if students don't feel that they have some challenge, they are not motivated. But if actually the challenge is too big, they also do not feel motivated. So these are indeed also quite a couple of theories that we can use and play a role if you think about creating these kind of AI systems. if you think about personalized learning or more adaptive systems that actually tailor to the levels of the students, and then we can assure more that students have good motivation in their learning as well. Yeah. Okay. Thank you.
Thank you. Other questions? Oh, many questions, I see.
Well, not so much a question, but just an idea. I was thinking about, I like to play chess at chess.com, and for me that's a wonderful environment where there's also training programs, and you have a clear defined learning score. And I was thinking, can you perhaps also work together with software of chess.com or Duolingo for the language, that's perhaps an environment with a lot of data, and you can perhaps tune in and get free data for doing the wonderful research and having some variations in support, learning support, and see what works best.
Yeah. Thank you very much for the suggestion and also the comment. So I see one thing in there that you're talking about more gamification a bit, right? If we have some goals or some scores, we usually like to learn a bit better. So we see that use of gamification as a good example in learning. And definitely all of these systems actually these days collect data. And definitely from educational technology or companies, they're really interested in to see like how can we utilize this data. Sometimes a bit more from a more profit perspective. So how can we ensure that the learners stay on longer? I usually want to make sure that they learn, but sometimes there is a bit of a combination there. Yeah, thank you.
I saw some questions in the back.
Thank you for an interesting presentation. I was wondering about the users, the target audience you have in mind, because I see you have executed some sessions with teachers, and you start your story by explaining self-regulatory learning. So who are in fact your users? Are those the students or the teachers?
Yeah, both. So this really depends on the project. So mostly I'm working with students in higher education. So that was also one of the first examples that I showed with the Canvas dashboard. But teachers are obviously also a user, because if you change something on the teacher side or the course side, that then hopefully also improves the learning for the students in the course. So both students and teachers are important stakeholders, but actually if we go further than that, we also see policymakers, educational policymakers, or people that are experts in course design, or so it is broader than that. But my focus is on both students and teachers in that sense. Yeah.
Thank you.
Are there any other questions? Yes, I see one more question there in the middle.
Hi, very insightful presentation. You rightly mentioned that visualization tools are not so effective, but we see more like plethora of more BI tools and more such graphical dashboards. My question is, what, in your opinion, would be a good visualization tool, if not just graphs, pie charts?
So good example. So you're focusing a bit like on the graphs, and then I feel a bit more on business analytics. So maybe even just getting the numbers out to see like how many students are there in the course, are they doing well? But if you're talking about improving student learning, things that might very much help is give the students something to reflect on, but also a step that they can take next. So, okay, based on my scores so far, I'm apparently lagging behind. What should I do now? Or what are steps that I could take to figure out what I need to do now? So one important thing is there, of course, if we are too prescriptive, then we get away from the self-regulated learning behavior, right? So we want to give them just the tools that can help them to act upon the data and go on, but not too much that they are not learning by themselves anymore. Yeah.
Okay.
It can still include pie charts and things like that, by the way. Yeah.
Final question.
I see that the whole research and studies which you are doing is focused on the process and very much dependent on the grades. But do you also challenge the grading system as the system which is actually not really good for the motivation of the intrinsic learning?
Yeah, very good question. I really don't like to grade on a product, actually. And these days, if you talk about generative AI, it doesn't also make sense to grade on the product, right? We can just have someone else create a product for us. It's more important what students are doing, and it's what is in the process and how they get to that final end product and how they critically reflect on what they get from different kind of tools. But there, it is more complicated to assess the process as well. I do feel it's a direction that we need to dive into, but yes, it's of course easier to just hold a multiple choice test in the end to see if students learn something. But I feel the learning is more in the process than in the end product. Yeah.
Thank you.
Okay. Yeah. Okay, thank you very much for this very interesting talk. Thank you. Please an applause again.